In today's lesson, we're looking to revise everything we know about quadratics. So let's start with solving quadratics. Now, while of course we could do this with our calculator, it's important that we think of solving quadratics as first letting everything equate to 0, then factorising, and then using the null factor law. Now, the null factor law states that if we have any two things that are multiplied together, let's call them A and B, if the answer was 0, then we know that at least one of them, if not both of them, had to be 0. Now this makes sense because if we're thinking what are two numbers we could multiply together, anytime we're doing that we're always getting something unless one of them was nothing. So let's look first at an expression like x squared plus 5x plus 6. Now this is a monic quadratic, mono because the coefficient or the leading coefficient is 1. And it's a trinomial, tri being 3, and nomial saying that there are 3 terms. Now you might remember that we could look at this as being in standard form ax squared plus bx plus c. And if we think because it's monic, because a equals 1, what are the factors of c that add up to b? So what are two factors of 6 that add up to 5? Well, it could be 1 and 6, or it could be 3 and 2. And in this case, it's 3 and 2. Now, because it's monic, we can simply replace this x squared plus 5x plus 6 with x plus 3, x plus 2 is still equal to 0. Making use of the null factor law, if we let our first thing equal 0, then we know that x is negative 3. If we let our second factor equal 0, we can see the answer is negative 2. Now it's always nice to give it in set notation. That is, x is an element of the set of numbers. Now we'll go most negative to most positive. So that would be negative 3 to negative 2. Now, we often will make an error when we're presented with a function like 5x squared minus 25x is equal to 0. One of the more common mistakes we could make is we would add 25x to both sides so that we got 5x squared equals 25x. And if we divide both sides by 5x, we end up with x equals 5. Now the problem with this is that we've ignored one of the answers. Trying to solve quadratics this way is not a recipe for success. So we'll rub that out and we'll look at first factorising. So we're going to use our same method, factorise, then null factor law. So how do we factorise something with two terms? Well, we can look back to the very first thing we learned, which is common factors. If I take 5x out as a common factor, I'm left with x minus 5 is equal to 0. Now by using null factor law, yes, we can see that x minus 5 equals 0, and one of the answers was indeed 5, but the answer we were missing was that 5x could also be equal to 0. Dividing both sides by 5, we can see x could be the thing that is 0. So in giving my answer a set notation here, I would say x is an element of the set of numbers 0, 5. In this regard, we know that x is either one of them or both. Occasionally we'll be presented with equations that are not equal to 0. Fortunately, it's easy enough to make them so. So if we think of our first step as needing the equation to equal 0, then in this regard, all I'll need to do is minus 5 from both sides. So 2x squared minus 9x minus 5 is equal to 0. Now that I'm looking to factorise this expression, if I recognise the fact that this is standard form, I'll see that it is non-monic. That is, the leading coefficient is not 1, it's a 2. So rather than just looking at the factors of c, I'll now be thinking, what are the factors of AC? A times C, in this case, is negative 10. Now, what are the factors of negative 10 that add up to negative 9? Well, of course, that's negative 10 and 1. So rather than just letting this be x minus 10x plus 1, there really are no shortcuts here. I'll need to replace that minus 9x with minus 10x plus 1x. So rewriting the expression, 2x squared minus 9x minus 5, I'm now changing this minus 9x to be minus 10x plus x. Now here I can choose to factor 2 and 2. You might know this as factoring by grouping. The common factor in the first bracket here is 2x, and I'm left with x minus 5. The common factor in my second bracket is 1, and I'm also left with x minus 5. Now let's not forget that this whole expression still equals 0. I can recognize that there's a common factor now of x minus 5, so that goes over here, and I'm left over with 2x plus 1. Now from this point on, this is no different to any other problem. We've factorized the expression, it equals 0, and we can use null factor law to say that either x equals 5, it's also possible, or it's the case that 2x plus 1 equals 0, or x equals negative 1/2. So giving my answer as a set, I can see x is an element of negative 1/2 or 5. Example 3, we have yet again a more difficult way to factorize this. Now we're going to do this two ways. If I'm thinking about factorizing, then I could take 4 out as a common factor. So if I took 4 out, I've got x minus 2 squared minus 9 equals 0. This is handy because it equals 0. If I divide both sides by 4, I'm left with x minus 2 squared minus 9 equals 0. Now at this point you may recognize a squared minus b squared. That is, a squared minus b squared is equal to a plus b, a minus b. So the square root of x minus 2 squared is x minus 2, and the square root of 9 is 3. And so in that regard, I've got x minus 2 plus 3 and x minus 2 minus 3. Or x plus 1, x minus 5 is equal to 0. So here, x is equal to negative 1, x is equal to positive 5, and as set notation, x is an element of negative 1, 5. Now this is perfectly reasonable to do. However, it is almost always better when I see something in turning point form to solve it what I'd call by brute force, similar to how you might solve linear equations. So suppose I had 4 outside of x minus 2 squared minus 36 equals 0. Well, the last thing that happened here was that we subtracted 36, so we'll add 36 to both sides. 4 outside of x minus 2 squared is equal to 36. If we divide both sides by 4, we'll see x minus 2 squared is equal to 9. Now to get rid of the squared, we're going to raise to the power of a half. And so we'll find x minus 2 is the square root of 9, which is plus or minus 3. Now as long as you remember this, you can't go wrong. So x is equal to 2 plus or minus 3. That is, x is an element, well 2 plus 3 is 5, 2 minus 3 is minus 1. And you can see that these answers are the same. Although it would be better to write this as negative 1, 5, as that's a set in ascending order. Just to summarize our understanding, we've got another non-monic here. So I mean to say a non-monic trinomial. So we're thinking, well, what are my factors of AC? Well, that's 3 times negative 2, so that's negative 6. Now what are the factors of negative 6 that add up to positive 5? In this case it's 6 and minus 1. So I'm going to replace 5x, whoops, sorry about that. I'm going to replace 5x with 6x minus 1x. So I've got 3x squared plus 6x minus x minus 2 equals 0. Now if I group 2 and 2, so the coefficient of this x is minus 1x. I can see here that my common factor, 3x, yields x plus 2 remaining. My next common factor is negative 1, because that's negative x minus 2. That also yields x plus 2. And so I can see here that I've got 3x minus 1, x plus 2 equal to 0. And my answer, by using null factor law, is x equals 1/3 and x equals negative 2. Putting that answer in context, x belongs to the set of numbers negative 2 and 1/3. Now we could also solve this on our calcs. Now in order to do that, I'll just press keyboard from the main menu. I'll use this solve button here, and I can type it in exactly as I see it. Now once we've done that, it's important to make sure that we press comma x. So we're telling the calculator or the computer what is the argument that we're solving for. Once we press execute, we'll see that our answers are negative 2 1/3 as we calculated previously. The final type of quadratic equation we get are quadratics that actually don't often look like quadratics at all. Now in this case, we can see that we've got something squared plus something to the power of 1 plus something whose a coefficient of the power of 0. So really, what I'm saying is we have something that looks like ax squared plus bx plus c. Now it's not entirely easy to see this, but imagine we made a simple substitution. Suppose I said let a equal x plus 2 squared. If this is the case, then my expression is now 6a squared plus a minus 1 equals 0. And so I could think, well, what are the factors of AC? Well, the factors of negative 6 that add up to 1, well, they could be negative 3 and 2, or 3 and negative 2. Now, because I need a positive number, these are the factor pairs that I'm going to choose. So I've got 6a squared plus 3a minus 2a minus 1 equals 0. If I factor by grouping, 3a is a common factor, and 2a plus 1 is remaining. Minus 1 is a common factor, and 2a plus 1 is remaining. So my final factored form is 2a plus 1 times 3a minus 1, and that equals 0. If we use null factor law, a is equal to negative 1/2, or a is equal to 1/3. Now it's important here to remember what was a. Well, I let a equal x plus 2. Sorry, didn't let it equal x plus 2 squared, I let it equal x plus 2. So x plus 2 is equal to negative 1/2, or x is equal to negative 1/2 minus another 2. So that's going to be negative 5 over 2. Here, x plus 2 equals 1/3. So x is going to be 1/3 minus 2. So that's a bit like saying minus 6 over 3. And we end up with negative 5 over 3. Now we could check our answer here, again by using our calculator. So we're just going to type that in, just like that, and as we press solve, we can see that indeed minus 5 on 2 and minus 5 on 3 are our answers. So it's important to recognize that what we're presented with may not always immediately appear to be quadratic. In fact, sometimes this might look like 6 times e to the 2x plus e to the x minus 1. In fact, it might be 6 times 2 to the 2x plus 2 to the x minus 1. It might even be 6 times cos squared x plus cos x minus 1. But as long as we have something that's of order 2, of order 1, and of order 0, when we can recognize the quadratic form, we could just make a simple substitution and solve it as such. Our next major skill comes by way of sketching quadratics. So we're going to start by sketching in standard form. Now in the notes above, I've given you lots of examples of what we mean when we say the dilation of factor a from the x, the dilation of n from the y, or really 1 on n, and what these translations mean. Now we're going to do a lot more of that in transformation, so if you didn't entirely understand it, that's fine. What's important to understand though is when we're sketching something in turning point form, we're able to establish what we know. So by looking at this, y equals negative x plus 1 squared plus 4, I can see the negative out the front of that makes this a reflected graph. Always when I think of this, I think, well, negatives make me unhappy, this will be a sad graph. It's going to go down with time. I can see my turning point is negative 1, 4. So just starting by what I know, if I think my turning point is negative 1, 4, my shape is going to go down with time, then negative 1, 4 looks like this. And recognizing that this will go down with time should help me see that there are both two x-intercepts and a y-intercept here. So, how would I find the y-intercept? Well, the first thing I can do is let x equal 0. So if y is equal to negative x plus 1 squared plus 4, then I can see that my y-intercept is equal to 0 plus 1 squared, then times by negative 1 plus 4. So I'm left with negative 1 plus 4, and that evaluates to 0, 3. So I know that this point here is 0, 3. I can see this shape isn't quite going to work out, so I'm just going to move my turning point over to be a little bit closer. So here we've got negative 1, 4. This should make it a nice smoother join as it passes through the y-axis. Now I can find my x-intercepts by letting y equal 0. So if negative x plus 1 squared plus 4 is equal to y, well, I know that I can find the x-intercepts by letting this equal 0. Now what we just covered is when I see something in turning point form, I can often solve this by brute force. So if I subtract 4 from both sides and divide by negative 1, we'll see that x plus 1 squared is equal to 4. That is, x plus 1 is equal to plus or minus 2, that's the square root of 4, and x is equal to minus 1 plus or minus 2. That is, negative 3, 0, and positive 1, 0. So I know that that's there, and that's there. We'll label it negative 3, 0, 1, 0. So to complete my shape, I'm going to think, there goes my quadratic. I might just move that point a little bit over. So redraw the axes and add in that point. There we go. Finally, to make sure that we get the marks, we need our shape to be one solid line. It's a little bit harder to achieve in the digital pen than by hand. We need to label x and y. This graph was given to me as y equals, so my answer should also be y equals. And I need to label y equals negative x plus 1 squared plus 4. So what happens when we're presented with something that isn't in turning point form? Here we can see we've got something in standard form. So what I know just by looking at it isn't much different. First, I can see from the leading coefficient that there is no negative. So this is a happy graph. I also, rather than seeing the turning point right away, can tell the y-intercept right away. Because if I let x equal 0, the only remaining thing will be that constant term. So my y-intercept is negative 12. Now to find the turning point, I can think that x of the turning point, so this is what I call the axis of symmetry, x of the turning point is equal to negative b on 2a. So that is negative 1, because this is my b term, divided by 2 times 1, because this is monic. So I find that the x part of my turning point occurs at a half. If I think, what is y of a half? Well, that's 1/2 squared minus a half minus 12, which is 1/4 minus a half minus, now I'd like to get some common denominators here, so I'm going to say 48 on 4. 1/4 minus a half is minus a quarter. Take away a further 48 quarters, and we're left with 49 on 4. So I know that my turning point is 1/2 minus 49 on 4. My y-intercept is 0, negative 12. And the shape of my curve looks like this. So the last thing to label is my x-intercepts. Now, if I think x squared minus x minus 12 equals 0, what are the factors of negative 12 that add up to negative 1? That's negative 4 and 3. So if I factorize this as x minus 4, x plus 3 equals 0, I can see x equals 4 and x equals minus 3. So I can plug these in, and I've done most of the work. What's left is to label x and y, and to say that y equals x squared minus x minus 12. Now it's important here, although they're not the best arrowheads, with the digital pen it's a bit harder, I need to make sure that there are little arrowheads here. That's because this does not have a restricted domain. If I just left it blank, the examiner might get that confused with closed dots, indicating that there are endpoints to this graph, which there are not. Another key skill which we need to recall from Year 11 is finding the equation of a quadratic curve. Now, in class we did the proof, but all you really need to know is that turning point form, the standard equation, looks like this. If I was given a turning point, this is the standard equation you should use. Standard form, as a general equation, looks like this. Here I will need to be given 3 points, but this is especially effective if one of those points was the y-intercept. Finally, I could consider my intercept form. If I know what the two x-intercepts are, that is, x1 and x2, then I'd only need one other point in order to find a. So it's important that we're able to recognize the standard forms, as this will save us a lot of time. If I was given a turning point, this is the one I'd use. If I was given 3 points, this is what I'd use. And if I was given the x-intercepts and one other point, then this is the one I'd use. Both of these require 3 points and are effectively interchangeable, but the one at the bottom will save you time. So suppose we're presented with this question. The equation of a parabola that passes through the point 211 and has its vertex at -1, 4. Well, we're asked to find the equation of the parabola. I know that it passes through 211, so that's just a standard point. I also know that it has its vertex, that's another way of saying turning point, and that vertex is -1, 4. So my standard equation here should be turning point form. If y equals a outside of x minus h squared plus k, then I can replace that h and k with -1 and 4. So here I could say y is equal to a outside of x plus 1 squared plus 4. So I still need to find this a. The way I do it is to use 211. So y equals a outside of x plus 1 squared plus 4. That point 211 literally means when x is 2, y is 11. Now 2 plus 1 squared is 3 squared, which is 9. So I'm saying 11 is equal to 9a plus 4, which if I bring the 4 over and divide by 9, a is equal to 7 over 9. Putting that back into context, y is equal to 7 over 9 times x plus 1 squared plus 4. And so my answer is A. Here we're given effectively the same question. We're asked to find the equation of the curve, only rather than being given it passes through a point or its vertex is, we're given an image. But from that context, we can determine that h is -2 and k is -10. We can also determine the point 0, -6. So this question has still given us all the information we need. It's just done so in a slightly more difficult manner. If I use y equals a outside of x plus 2 minus 10, so that's me subbing in my turning point. I know that I need to say when x is 0, y is -6. So when y is -6, x is 0. So -6 is equal to 4a minus 10, and a is equal to 1. So this is all well and good, except my answer, x plus 2 squared minus 10, is not present there. I can see that they've all been expanded into standard form. So I'll need to do the same thing. This will be x squared plus 4x plus 4, if we remember our difference of perfect squares, minus 10 yields x squared plus 4x minus 6. And so x squared plus 4x minus 6, that gives me an answer of A. Now this I guess 12 part A is something that you'll easily do. We've done quite a few exactly the same. So I'm going to skip down to 12b. It says a parabola has x-intercepts of -1 and 2 and passes through the point 3, 6. Now I could set this up as a set of simultaneous equations. But if instead I look at what I've got x-axis intercepts of -1 and 2. The passes through bit is my usual point, and I'm being asked to find the equation of the parabola. Well, because I was given x-intercepts, let's start with the fact that y is a outside of x minus the first intercept, x minus the second intercept. Well, my first intercept was -1, and my second intercept was 2. And so I get y equals a outside of x plus 1, x minus 2. Now I'm also told that when x equals 3, y equals 6. So 6 is equal to a outside of 3 plus 1, 3 minus 2. Well, that's 1, that's 4. So if 6 equals 4a, a is equal to 3 over 2. Putting that into context, y is equal to 3 over 2, x plus 1, x minus 2. So we can find the equation of a parabola as well, provided we're given either 3 points or the turning point and one other point. If you remember back to calculus, the turning point can always be thought of as giving us 2 pieces of information, and so it's really quite handy. So the last couple of skills which serve as revision for us is to complete the square and to use the quadratic formula. Now whenever we're completing the square, and I did this proof in class, you might remember that we can simply use this formula. As long as I've got a as 1, so as long as we have a monic quadratic, we could say that we've got x plus b over 2 squared minus b squared on 4 plus c. So looking at my question down the bottom, it says complete the square to factorize this expression. Well, the first thing I need to do is take out negative 2. So I get x squared, this will be minus 3x plus 4. Now as long as I remember this negative 2, I can just chuck it in right at the end. If I think that my a is now 1, my b is negative 3, and my c is 4, to complete the square, I just need to do x plus b on 2 squared minus b squared on 4 plus c. Subbing in the values that I have, we can think, well, x is equal to minus 3 on 2. Then I've got minus 3 squared on 4, and my c value is 4. So I've got x minus 3 on 2 squared. Well, 3 squared on 4 is 9 on 4. So I've got minus 9 on 4, and 4 is plus 16 on 4. So I'm left with x minus 3 over 2 squared plus 7 on 4. Now the thing that we had to remember was that all of this is multiplied by negative 2. So if I double everything, I'll get minus 2x minus 3 on 2 squared, negative 2 times positive 7 on 4, well that's just minus 7 on 2. So this is a very easy way for me to factorize by completing the square. I could further this by using dots. If I kept the negative 2 out and I had x minus 3 on 2 squared plus 7 on 4, well, I'd see here that this is a plus and not a minus. So in this case, this expression can't be factorized any further. If it was a minus, we might be able to use difference of 2 squares. Last thing for this video is that we're going to review the quadratic formula. Now this is really simple, but it's important to note that this will only ever work when the equation equals 0. That's why we started this video by making sure we bring everything to the left, or we make sure that everything is equitable to 0. So the first thing that I might do is just label. A is negative 3, B is negative 12, C is negative 7. This might seem arbitrary, but it's really good to label so that you know you don't make mistakes with negative numbers. Now my x here, because this equals 0, is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. It's long, it's boring, it's arduous, but you do need to remember it. And if we sub in what we have, I know that my b was negative 12. So negative of that just means change the sign of the thing you see. So that's now 12. Negative 12 squared, so my b squared is 144. Negative 4 times negative 3 is positive 12. Positive 12 times negative 7, that's that extra c, is minus 84. So when I evaluate this, I'm left with 12 plus or minus the square root of 60. Now we've got to go all over to a. Now a in this case was -3. This will be divided by -6. Now this answer is not bad, but it's not simplified, because the square root of 60 could be the square root of 4 times the square root of 15. So we get 12 plus or minus 2 root 15 over -6. Well, 2 goes into -6 3 times and 12 6 times. So I've got 6 plus or minus root 15 over -3. Now I don't like the negative at the bottom, so I'm just going to bring it to the top. If I multiply the bottom by -1 and the top by -1, I'll get -6. Now really I might think, oh, that's minus or plus now, but that's the same as plus or minus. So multiplying that bit by -1 has no effect. And so I can literally just bring that minus to the top. So x has two answers here, -6 plus root 15 on 3, and -6 minus root 15 all on 3.